Dr. Chen, I'm really scratching my head over this one. The problem wants me to use Hess's law to find delta H for the target reaction carbon plus 1/2 O2 yields carbon monoxide, given some reactions and their delta H values, and also to provide intermediate reactions for carbon yields. Carbon dioxide and carbon monoxide yields carbon dioxide. I'm just blanking on how to even start this. Which piece do we usually reach for first with these kinds of problems?
I can see why this one's giving you pause, Sam. The real trick with Hess's law problems is often knowing how to manipulate the given reactions to build your target reaction, especially when the intermediate steps aren't explicitly laid out for you. You've already identified the target reaction. C plus 1/2 O2 yields carbon monoxide. What are the two intermediate reactions the problem provides, along with their delta H values?
Okay, so the problem implies the two intermediate reactions are C plus O2 yields carbon dioxide and carbon monoxide plus 1/2 O2 yields carbon dioxide. I remember those values, I think. So, for solid carbon plus oxygen gas yields carbon dioxide gas, delta H is plus 393.5 kilojoules. And then for carbon monoxide gas plus 1/2 oxygen gas yields carbon dioxide gas, delta H is negative 283.0 kilojoules. Is that right?
You've correctly identified the two intermediate reactions, Sam. Those are exactly the ones we need. However, let's take a closer look at the delta H value for the first reaction. Solid carbon plus oxygen gas yields carbon dioxide gas. Remember that the combustion of carbon to form carbon dioxide is typically a highly exothermic process, meaning it releases heat. How does that relate to the sign of delta H?
Oh, right. Exothermic means it releases heat, so delta H should be negative. I must have mixed up the sign. So for solid carbon plus oxygen gas yields carbon dioxide gas, delta H should be negative 393.5 kilojoules, not positive. Thanks for catching that, Dr. Chen.
Excellent, Sam. You've correctly identified that for an exothermic reaction like the combustion of carbon, delta H should indeed be negative. So, solid carbon plus oxygen gas yields carbon dioxide gas has a delta H of negative 393.5 kilojoules. Now that we have the correct delta H values for both intermediate reactions, how do we combine them using Hess's law to get our target reaction, solid carbon plus 1/2 oxygen gas, yields carbon monoxide gas? What's your first thought on manipulating these equations?
Okay, so I think I need to keep the first reaction. Solid carbon plus oxygen gas yields carbon dioxide gas, as it is because carbon is a reactant in our target reaction. Then, the target reaction has carbon monoxide as a product, but my second intermediate reaction, carbon monoxide gas plus 1/2 oxygen gas yields carbon dioxide gas, has carbon monoxide as a reactant, so I need to reverse that one. So, it would be carbon dioxide gas yields carbon monoxide gas plus 1/2 oxygen gas. Then, don't I just add the two delta H values together, so negative 393.5 kilojoules plus negative 283.0 kilojoules?
You're absolutely on the right track with manipulating the reactions, Sam. Keeping the first reaction as it is and reversing the second one is exactly what we need to do to align with the target reaction. However, what happens to the delta H value when you reverse a reaction? Think about how the energy flow changes when a process is run in the opposite direction.
Oh, right. When you reverse a reaction, you have to reverse the sign of its delta H value too. So, the reversed reaction, carbon dioxide gas yields carbon monoxide gas plus 1/2 O2 gas, would have a delta H of plus 283.0 kilojoules, not negative 283.0 kilojoules. My bad. So then, for the target reaction, I would add negative 393.5 kilojoules and plus 283.0 kilojoules.
That's exactly right, Sam. Reversing a reaction means you must reverse the sign of its delta H. So, for the reversed reaction, carbon dioxide gas yields carbon monoxide gas plus 1/2 molecule of oxygen gas. The delta H becomes plus 283.0 kilojoules. Now, you have the correct delta H values for both reactions in their manipulated forms. What do you get when you add negative 393.5 kilojoules and plus 283.0 kilojoules together?
Okay, so when I add negative 393.5 kilojoules and plus 283.0 kilojoules, I get negative 110.5 kilojoules. Does that sound like the right delta H for the target reaction carbon plus 1/2 O2 yields carbon monoxide?
Yes, that's absolutely correct, Sam. When you sum the adjusted delta H values, negative 393.5 kilojoules and plus 283.0 kilojoules, you get negative 110.5 kilojoules. That is indeed the delta H for the target reaction solid carbon plus 1/2 O, 2 gas yields carbon monoxide gas. Congratulations, you've solved the problem. To summarize, we started with the two intermediate reactions, made sure their delta H signs were correct, then reversed the second reaction and flipped its delta H sign, and finally added the delta H values to find the enthalpy change for our target reaction.
Oh, awesome! Thanks so much, Dr. Chen. I definitely learned a lot about remembering to flip the sign of delta H when reversing a reaction, and how those intermediate steps really come together. This makes a lot more sense now.